So in this problem, we're going to look at determining the empirical formula for a compound. MSG, a flavor enhancer, contains 35.50 or 51% carbon by mass, 4.77% hydrogen, 37.85% oxygen, 8.29% nitrogen, and 13.60% sodium. So if we know these are all in percent, we can make an assumption that in a 100-gram sample, we will have each of these in grams. So what we're going to do is we're going to assume 100 grams. So we'll have 35.51 grams of carbon, which we will then convert to moles. Using the molecular weight of carbon, which is 12.01 grams carbon and 1 mole of carbon. In this case, the answer here is going to be 2.96 moles of carbon, okay? Now for the next element, for hydrogen. We're gonna start with 4.77 grams of hydrogen. We're gonna use the molecular weight, which of 1.1 grams. In this case, we'll have 4.72 moles of hydrogen. Next, we'll use oxygen of 37.85 grams of oxygen, using the molecular weight of 16 grams and 1 mole. In this case, we have 2.36 moles of oxygen. Trying to run out of space here. Next, we'll use nitrogen, which is 8.29 grams. We'll use the molecular weight of 14.01 grams and 1 mole. 0.59 moles of nitrogen. I'm going to skip down here to the bottom, then we'll come back up. We'll now use our 13.60 grams of sodium. Using the molecular weight of 22.99 and 1 mole, we get 0.59 moles of sodium. So the question is what to do with all of these moles. So in this case, one of the issues that we're going to have is we're going to go and we're going to divide by the lowest quantity of moles. So we have 2.59s. This is going to allow us to convert all of these numbers into real or hopefully whole numbers. So it turns out that 2.96 divided by 0.59 is equal to 5, okay? 4.72 divided by 0.59 is equal to 8. This gives us the ratio of all of these components in our empirical formula, which is what the question is asking. For oxygen, we have 2.36 moles divided by 0.59 moles. This is going to give us 4 moles. 0.59 divided by 0.59 is 1, and the same goes for sodium when I ran out of space. So now the empirical formula just uses all of this. So we have 5 carbons, 8 hydrogens, 4 oxygens, a nitrogen, and a sodium. Okay? So if we remember back to the discussion of empirical formulas, we remember that empirical formulas and molecular formulas are often in relationship by a whole number. So if we have the molecular mass assayed in a different method and the empirical formula, we can determine using the ratio of the molecular weight divided by the empirical weight This is equal to the whole number ratio between the molecular formula and the empirical formula. So in this case, the empirical weight is going to be equal to the sum of all of these. So we have 5 times 12.01 for carbon, plus 8 times 1.01 for hydrogen, plus 4 times 16 for oxygen, plus 14.01 for nitrogen, and plus 22.99 for sodium. And all of those added together are 169.13. In this case, the molecular weight that we calculated, or that was determined for us, is 169 divided by 169.13 is approximately equal to 1, which means that in this case, the empirical formula is the molecular formula. So we'll just rewrite what we found before. And so the molecular formula is the same as the empirical formula for this problem.